So today we're actually going to focus mostly on just finding zeros and finding a polynomial from zeros. We're going to start off with that. Okay, so if you had a quadratic function and you used the quadratic formula to find the zeros, you would then plot those zeros. Another way to do it would be if you had a quadratic equation and you then factored it. And let's say your factors came out to be x plus 2 times x minus 4. Okay, if you had this quadratic, what would the solutions be? How would I find them? Yeah.
FOIL first.
Well, that would give me the quadratic that it came from. We're going to do that in a second. I'm saying if you already had it factored and you're trying to solve or find the x-intercepts. Okay, you even jumped a little bit ahead of where I was going to go. Wouldn't you set each of these equals to 0? Okay, so x plus 2 equals 0 and x minus 4 equals 0. X equals negative 2, x equals positive 4 are your what we call solutions. They're your x-intercepts. Okay, and then we would go plotting them on the x-axis and so forth. What Jared brought up a second ago is that what your x values are when you set each factor equal to 0 and solve appears, this is important, appears opposite as it was in your parenthesis group. So like the 0 of x equals negative 2 came from your factor of x plus 2. And your 0 of x equals 4 came from x minus 4 for a factor. So after we know the factors, then we could multiply them together to come up with a polynomial. That's one of the tasks for today. Okay, we're going to have two tasks for today. One, we're going to come up with a polynomial given the zeros. Given the zeros, give me a polynomial. The other thing we're going to do is we're going to start with a polynomial and we're going to find the zeros. Okay, and we will probably factor to find the zeros in the second task. Okay, first we're going to start off with given the zeros, let's find the polynomial. That one's generally easier for people, and we're going to work with this specifically, where what you see is x equals, it's opposite of what it was. You have to kind of undo the solving. Okay, you have to get equal to 0, and then those are your factors. So let's do one together. Okay, so let's say that I give you the zeros of x equals x equals 5, negative 2, and let's even go a third one, and let's go positive 1. Okay, the task will be write a polynomial. With the given zeros. Okay, that's what you're trying to do. If I can write the factors, then all I have to do is multiply the factors together. So, if I have a 0 of x equals 5, what's the factor that comes from? Get this equation equal to 0 and you'll have the factor. Okay, so instead of having x equals 5, to get it equal to 0, I would subtract the 5 over to be with the x. So x minus 5 equals 0. That right there is the factor that can give me x equals 5. Sometimes there's more than one solution. Like if I had, in fact, all the time, there's more than one factor that works. Okay, like if I had 2x minus 10, that would give me x equals 5 also. It doesn't matter which one you write down. Okay, they'll all be the same x-intercepts. All right. How about x equals negative 2? What's the factor that gives me x equals negative 2? I have x minus 5. X plus 2. Very good. Okay, because if you add the 2 to the other side to get equal to 0, gives you x plus 2. That's the factor. X equals 1 gives me a factor of what? X minus 1. Okay? So your three factors that need to multiply together to give you the polynomial are x minus 5, x plus 2, and x minus 1. To find the polynomial, then you just multiply them together. Okay, so this is actually equal to y. All right, the product of the factors is equal to your polynomial. And there are several correct answers. We'll talk about that in a second. Okay, like if you had written 2x minus 10 instead of x minus 5, you'll get a different product when you multiply them together. We are recording class because we have some absences. So that's what's going on with the lights being off. They get to focus in a little bit better on the video. You can see what's going on. So again, there's multiple correct answers. Let's multiply these together to find out what the polynomial would be without factored form. Okay, so how do I multiply three factors together like this? Yeah,
We take two, separate one while we FOIL.
Okay, FOIL two of them together first and then multiply the third one into that. So let's multiply the last two together first just because they're next to each other. Let's multiply those two together first. Okay, so x plus 2 times x minus 1 is going to be x squared plus x, right, inners and outers combined, minus 2 if I've simplified. That makes sense? Thumbs up or thumbs down? Got it? Those two multiply to be x squared plus x minus 2. That thing needs to multiply by x minus 5. Okay? To multiply by x minus 5, you can do it a couple of ways. Some people take x minus 5 times each term. Some people take x times each term and minus 5 times each term. That's the most common way that I've seen people do it. Let's do it that way. Okay, so x times each of these is going to give me x to the third plus x squared minus 2x, and then negative 5 times everything is going to give me minus 5x squared. I'm actually going to put that underneath this other x squared because it's like combining like terms. Yeah, Grace.
Should it be minus x?
Well, maybe. Where?
Like x squared minus x.
Well, I have plus 2x and I have minus 1x, so they combine to be plus 1x.
Okay.
Does that make
Yes.
sense? Good. Thanks for stopping.
Yeah.
But that was, we definitely want to make sure you understand where that came from first. Minus 5x times x squared, I'm going to put that underneath the other x squared term that I already have. Okay? And then minus 5x times x is minus 5 times x is going to give me minus 5x. I'm going to put that underneath the x's that I already have. And minus 5 times minus 2 plus 10. Okay? Good. Drop them down. X cubed minus 4x squared minus 7x plus 10. That can be an equation that equals your polynomial. Okay? Now, let me ask you a question. If you had 2x minus 10 for this first factor like we talked about a minute ago, you would still get a solution of x equals 5. That would change your final answer equation. How else can you change your final answer equation besides changing each one of these factors and how it looks?
Like switching the signs.
Switching the signs, very good. Multiplying everything by a negative 1. In fact, that just changes the direction that so if your graph is like an S, like this, and actually this one would go up to the right. So there we go. If it's an S that goes through the x-axis 3 times. Okay, so here's your x-axis. This one goes through at negative 1, positive 1, forgot what I was doing there for a second. and it goes through at -2, and it goes through at +5. Okay, and it goes up to the right. Okay, and it goes down to the left. My polynomial looks like this. If you were to multiply everything by a -1, that would just change the direction of your polynomial. It would flip over the x-axis. So your polynomial might look like this instead. Still goes through the x-axis at the exact same spots. There's nothing wrong with that. If you stretch the graph, multiply by a number that's not even negative, multiply by 5 or 3. Okay, that's going to make these hills and valleys longer, but it's not going to change where you cross the x-axis. Does that make sense? So there are lots of correct polynomials that go through these positions on the x-axis. If I go back up here to my multiplication, if I put a 2 in front of this, then I multiply by entire polynomial by 2, that doesn't change any of my factors at all, any of my solutions at all. Because 2 equals 0 doesn't give me any values for x. Doesn't give me any additional values for x. So multiplying by a constant does not change your zeros at all. Okay? This is how you will then find a polynomial given the zeros. Does that make sense? You find the factors, that's the biggie. That's the big step. Okay, you find the factors that those zeros came from, and there can be multiple correct answers for those. You may not have the same answers as your other group members, and that's okay. As long as your factors give you the correct x values, then you're good. As long as you do your multiplication correctly and coming up with the polynomial, you should be fine. Okay? All right. We can practice another one of these, but I definitely want to make sure we spend enough time on the second task, which is finding the zeros from a polynomial, because that one tends to trip people up more. Okay? And we'll actually be spending all of section 3 going over how to do this. Okay? So what happens if it doesn't factor? Well, that's kind of a tricky question. We won't deal with that today. Okay, we'll deal with it tomorrow. Well, but that's only if it's a quadratic. What if it's a cubic? That doesn't factor. Well,
And then you suffer.
yeah, something like that. There's not really. There's definitely a way to do it. It's just not fast. There's nothing nice and neat like the quadratic formula. Only in precalculus would you call the quadratic formula nice and neat, right? It's long, but at least it always works. With factoring by the binomial theorem, you have to find like things that could be factors, and there's this answer bank of all these possibilities. At least it's a finite number of them, okay, that could work. And the rational zeros is how we do that. We'll talk about all of that tomorrow. Okay, today, what you're given should be factorable. Okay? Forgot to talk about one more thing with this. What if I don't know how many of the x equals 5 solutions I had? Like, what if I made one of these a square or a cube? Well, does that change my zeros at all? If I put a cube on this x minus 5, and let me just do it. Okay.
You get a positive and a negative, because if it was squared, then you'd have to, I guess it
Plus and minus the square root of 0. You do the square root of the other side. So when you're setting that, so if I made this x minus 5, and let's just take a minute to do that. If I had x minus 5 quantity cubed or squared or to the 4th, if I change the power of one of those factors and set it equal to 0, does that change my solutions? What does it mean to have something cubed? So really, you have x minus 5 times x minus 5 times x minus 5.
So you'd have x cubed
Wait a minute, keep straight where we're trying to go. Does this change my solutions?
You have x times 0, x times 5.
Save me from writing it 3 times, right?
Yeah.
Just write it once.
Yeah.
Same answer every time because it's the same factor every time. You still only get x equals 5 out of this equation, okay? Here's what that does for you. This changes what's called the multiplicity. Okay, I had 3 x minus 5 factors. They all 3 gave me x equals 5 as a solution. So therefore, the multiplicity is 3, but the solution is still only x equals 5. All right? The multiplicity just tells you how many times you had that factor occur. It can change what happens at that 0. So you know how we've seen cubics? I think we had one last Friday when I was showing you graphs on Desmos. We've seen cubics that just come up, bounce off that, and come back down. That's because it has a higher multiplicity than 1. Okay? So really, to ask you for a polynomial, I need to tell you more about it. I need to tell you, find a 3rd degree polynomial. That means x cubed is your highest power. Find a 3rd degree polynomial with these zeros. Then you could tell me, oh, none of these have multiplicity more than 1. They all have power of 1 because I have 3 of them and I need a cubic. I need
But if it
degree
tells
3.
you, like, if it tells you to find, like, one with a 4th of power, and it only gives you 3 one of them.
Right. One of them has to be to a higher power than just 1. Let's do one of those. I'm going to backtrack it. Okay, so let's do one of those. Let me tell you that you have find a polynomial, and it's still going to be more than 1 because you could still multiply everything by a constant. It doesn't change your solution. Okay, so find a polynomial with the following qualities. Let's say that you have a 0 of -1, multiplicity of 1, a 0 of 3 with a multiplicity of 2, and a 0 of 0 with multiplicity 1. And I want this to be degree 4. Okay, so find a polynomial with these qualities.
Is that how it will be laid out in our book?
It is.
Okay.
It is. I looked at your book specifically to find out how they would lay it out, and they may even tell you more, like, let's throw that in there. Let me tell you that it's going to fall to the right. Okay? Ready? First thing we're going to do is take these zeros and we're going to come up with the factors that they go with. Okay, that they came from. Bless you. So over here, I'm going to take each of these zeros and I'm going to turn them into the factors they're supposed to come from, or they could have come from. So the 0 of -1, what's the factor that can come from? Do you want to try it? X plus 1. Very good. That can come from x plus 1. There's more than one right answer, but x plus 1 is probably the most basic one that everybody will come up with. Okay, we'll deal with multiplicity in a second. But the 0 of x equals -1 gives me x plus 1 as a factor. What's the factor that gives me the 0 of 3?
2x minus 6.
That'll work. X minus 3 is probably the most basic one that everybody would come up with.
Well, I'm doing that to the multiplicity.
Oh, that doesn't change. Doesn't change your factor. It changes how many times that factor occurs. I'll show you what that does in a second. Okay, it puts a 2 in the exponent, not out in front. Good, good. Glad we talked about that. What about x equals 0? What's the factor? X.
Yeah, just X.
X plus 0, or just x. Okay? All right. This is supposed to, the first factor, x plus 1, is supposed to have multiplicity of 1. That means it's x plus 1 to the first power. X minus 3 is supposed to have multiplicity of 2. What that does is it tells me I'll have an exponent of 2 on this. Okay? And x equals 0 is supposed to have multiplicity of 1. So x has an exponent of 1. Okay? So really, you have the polynomial x plus 1 to the first times x minus 3 quantity squared times x to the first. And we might put that one out in front. If I were to multiply these together, I would get a polynomial that works. However, is it degree 4? Let's take these two things into account. Degree 4. Well, maybe I should multiply it out to find out if it's degree 4 or not. Is that okay? So let's multiply this out. I'm going to take a shortcut here with you because of time. X minus 3 quantity squared is going to give me x squared minus 6x plus 9. It's that first one squared, double the product, second one squared. Okay? That thing needs to be multiplied by x to the first and by x plus 1. Let's multiply the x plus 1 through. Okay? So I'm going to multiply everything by x, and then I'm going to multiply everything by 1. And combine like terms. This times x right here is just going to factor on through. So x times x squared is going to give me x to the third. X times negative 6x is going to give me negative 6x squared. X times 9 is going to give me plus 9x. 1 times x squared is going to give me x squared. 1 times minus 6x is going to give me minus 6x. And 1 times plus 9 is going to give me plus 9. So those two things FOILed or multiplied are going to give me x cubed minus 5x squared, very good, plus 3x plus 9. But you still need to multiply by this x, okay? Still need to multiply by this x. That's just those two things multiplied together. So let me write that down. This whole thing times x. Distribute the x through. That's always the easiest last step, in my opinion, is to distribute a single thing through. Okay? If you want to do it first, you could. So x cubed times x is going to give me x to the 4th. It's degree 4. That's what I needed. X times minus 5x squared is going to give me minus 5x to the 3rd. 3x times x is going to give me 3x squared plus 9x.
What if it wouldn't have been to the degree of 4?
It will, and here's why. Okay? Let me punt for a split second on that question. Okay? But it will, is the answer. All right. Taking care of degree 4, it was x to the 4th for the degree. What about this right here? Does it fall to the right? What does falling to the right mean that my polynomial should look like? Yeah.
It should like go.
Yeah, how do I make it go down to the right? Take it times a negative something. It doesn't even matter if it's a negative 1. It could be any negative number, as long as it's a negative. So we still need to make this thing fall to the right. So I'm going to multiply by negative something, okay? Negative 1 times this whole thing. This is making the positive or negative leading coefficient. It's making that leading coefficient the right sign. Okay? So that's going to give me a final equation of possibly negative x to the 4th plus 5x to the 3rd minus 3x squared minus 9x equals y. Again, your equation could be different because you can actually multiply by any negative number here. It doesn't have to just be negative 1. Okay, Brenna, you asked the question a second ago, so this could be your final answer. You asked a question a second ago, what if your degree doesn't match? Look at your multiplicities.
Oh,
They add up to 4. That should always happen. You should always, your multiplicity should always add up to the correct degree. Does that make you feel better?
Mm-hmm.
Okay, good. Let's do a couple, or one at least, where you have to find the zeros given the polynomial. I know. What, 2 minutes?
Like less than a minute.
Less than what?
Oh, you're so full of it. No, don't get 4.
That is possible.
Possibly. Let's do one where you have to find the zeros. This is going to be where you need to factor. Okay, that's your entire goal today, is to factor completely so that you can set each factor equal to 0. So task 2, find the zeros. This is a really, really big concept, and the entire section 3 is designated to it. But if I ask you to find the zeros, and let's do one of these, okay? F of x equals 2x to the 4th minus 6x squared plus 1. Okay, so this isn't, just let me walk through it since we're short on time. This is an x to the 4th graph. Great. I don't know how to factor an x to the 4th. You use your same factoring techniques that you learned in Algebra 1 and Algebra 2. Okay, so if this looks like a quadratic, except it's an x to the 4th, does that bug you? It'll actually be treated kind of like a quadratic. So this thing might factor like this, 2x squared and 1x squared would multiply, first terms would multiply to be 2x to the 4th. Because there's no plain x cubes or x's, you won't have any other x's in your factors. You'll just have x squareds because your inners and outers would have to be x squareds. Okay? So this thing could factor, it can either be plus 1, factors of the last one need to be put in the last positions. Does that work though? It doesn't. So this, and if I change it to minus 1 here and here, is that going to make anything, is that going to heal all wounds here? No. So this thing does not factor. What I need to do is use the quadratic formula. This is what I call a quadratic in disguise. Anytime you have the powers decreasing by half, see how it goes from 4 to 2 to nothing? Anytime you have that behavior, you have a quadratic in disguise, and the quadratic formula applies. There's one change. Instead of just equaling negative b plus and minus the square root of b squared minus 4ac all over 2a, you will equal not plain x over here, but you'll equal x squared. Very good. It's whatever the middle term's x power is. Okay, so I'm going to put this on here, but we'll definitely continue with this tomorrow. Page 113. Numbers 49 through 51. And 55. And let's stop there. Okay, I'm not giving you any of the ones where you actually have to find the zeros because we didn't get to it. We'll deal with those tomorrow.